everybody, in this video we're going to discuss dividing complex numbers. So if you haven't seen my video and learned how to multiply complex numbers, I highly suggest that. Because the ideas of dividing complex numbers is really just two multiplication problems in disguise. So here's the premise, very basic. We have 7 plus 4i divided by negative 3 minus I. The idea is we don't want imaginary numbers, or therefore complex numbers, to show up in the denominator. AKA, we don't want i's to show up in the bottom. So the goal is we need to kind of move things around and multiply by things in order to make sure all the i's go away in the denominator, the bottom. So what we're going to use is something called complex conjugates. Okay, here's the idea there. If you see, say, 3 plus 2i, the complex conjugate that you would multiply by is you keep the 3 and you keep the 2i, so the 3 and the 2i are the same. There was already addition in the middle, so now I'm going to do subtraction. Okay, these are complex conjugates. The front, the real part is the same, the imaginary part is the same. All I changed is one of them is addition, one of them is subtraction in the middle. Those are complex conjugates. Another example, if you had like 7 minus 5i. So I'm going to keep the 7, I'm going to keep the 5i. I had subtraction already, so now I'm going to use addition. Okay. Another example of a complex conjugate, if we had like negative 2 minus 8i. So this one kind of tricks kids out. Keep the negative 2. Keep the 8i. The focus is entirely on the middle. We had a subtraction, so now I have an addition. And one final example, just to kind of cover all possibilities, is what if I had negative 3 plus 4i? Keep the negative 3, keep the 4i, but change the addition to a subtraction. Now here's the point of complex conjugates. When you multiply complex conjugates together, what should happen in the simplification process is all the imaginary parts are going to go away. So you should only be left with a real number once you multiply complex conjugates. So again, the first part is the same, the back part is the same, it's the middle. Make sure one's addition, one's subtraction. One's addition, one's subtraction. So looking at our problem, I have 7 plus 4i divided by negative 3 minus I. Again, the focus is on the bottom. We want to eliminate the i's in the denominator. So what I'm going to do is, my focus is on the bottom, so I need to multiply by the complex conjugate on the bottom. So if I see negative 3 minus I, I'm going to multiply by negative 3 plus I. And on top. So anytime you multiply a fraction, if you're going to multiply the bottom, you have to multiply the top. If you multiply the top, you have to multiply the bottom. What we're doing there is we're essentially multiplying by 1 when you multiply the top and the bottom by the exact same thing. So since I multiplied the bottom by negative 3 plus I, I'm going to multiply the top by negative 3 plus I. So it's going to appear like we're really multiplying this by something pretty complex. You're really just multiplying this problem by 1. Okay, so it doesn't really change it. It's going to completely appear like we changed the problem. We're not really doing that. So what I'm going to do is I'm going to keep myself organized. I'm going to multiply the top, see what happens. And I'm also going to eventually multiply the bottom, see what happens, and combine my two answers together. So on the top, we're talking about 7 plus 4i times negative 3 plus I. So we've done multiplying already. Same kind of deal. Take this 7 times the negative 3, which is negative 21. Take the 7 times the I, which is 7i. Take the 4i and multiply it through. 4i times negative 3 is negative 12i. 4i times I is positive 4i squared. So trying to clean this up here, I have like terms in the middle with a 7i and a negative 12i. So the negative 21 is still here. 7i minus 12i is going to take me to negative 5i. And we talk about this 4i squared piece. We remember that I squared represents -1. So instead of 4 times I squared, I really have 4 times -1. 4 times -1 being -4. Continuing to try and simplify here, I have like terms of -21 and -4. -21 minus 4 takes us to -25, and we still have a minus 5i. So that was the top. I still have an I hanging around, but remember, we don't care about the top. The focus was entirely on trying to eliminate imaginary numbers on the bottom. So let's look at the multiplication that's going to happen on the bottom. We should have all of our i's go away. So what I had up there was -3 minus I times -3 plus I. So now we're off to distributing. So we're going to take -3 times -3, which is 9. -3 times a positive I, well, that's a -3i. Then we're going to take our -I and distribute it all the way through. -I times a -3 is a positive 3i. -I times a positive I is a -I squared. So now we go to the simplification process. Still got a 9. Got a -3i and a positive 3i. Those are going to eliminate there. And then we have a -I squared. Again, we have to take care of an I squared. Negative still there. I squareds we can replace or substitute with a -1. So we're left with a -1, which is +1. 9 plus 1 takes you to 10. So on the bottom, the denominator, when I distributed everything out with the complex conjugates, we are left with just a 10. That's what we wanted to happen. We wanted to get all of our real numbers to go away. So when I put all this together up top, I'm going to have a -25 minus 5i. On the bottom, I'm going to have a 10. I'm almost done there. I just have to simplify my fractions. So what I'm going to look at is I'm going to look at this left side. I'm looking at -25 divided by 10. -25 divided by 10. So I'm trying to simplify the fraction of -25 over 10. You could use a calculator if you're not really great at reducing fractions. This one's pretty basic. -25 over 10. Divide each of these by 5. You get -5 over 2. -25 divided by 5 is -5. 10 divided by 5 gets you 2. Then I'm going to move to the other part. So I'm taking top left divided by the bottom, top right, try and divide by the bottom. Need a subtraction in the middle. I'm going to try and reduce 5i over 10. We're really just focusing at 5 over 10. So reducing this, I could divide the top 5 by 5, you get 1. Divide 10 by 5, you get 2. And don't forget that you still had an I there. So reducing that fraction, we get -5 over 2 minus 1/2 I. This would be our solution to dividing those complex numbers. So again, you're looking at two multiplication problems. A multiplication problem on the top, multiplication problem on the bottom, but the focus entirely is on the bottom. Multiply by complex conjugates, and that will get rid of all the i's on the bottom. The top, you might still have some i's left over, and that's okay. Once you have your top and your bottom multiplied out, try and reduce the fraction.